Have you ever looked at a picture of our Earth from space? It's a stunning sight. A beautiful swirling sphere of blue, white, and green hanging in the blackness of the cosmos. We call it the blue marble, and for a very good reason. That brilliant blue, the color that defines our world, is water. It covers more than 70% of our planet's surface. It's so common, so familiar, that we often forget it's one of the most remarkable substances in the universe. In the grand, silent emptiness of space, our world is a vibrant, living oasis, and the secret to that life, the very engine of our world, is water. So why is water so special? What makes it the indispensable ingredient for life as we know it? The answer lies in its incredible chemistry. Water is often called the universal solvent. This means it has a remarkable ability to dissolve other substances. Think of it like a cosmic courier service. Inside our bodies, blood, which is mostly water, carries dissolved nutrients and oxygen to every single one of our trillions of cells. It's the perfect transport system, delivering the building blocks of life where they are needed most. Water has an incredibly high heat capacity. It means it can absorb a lot of heat without its own temperature increasing very much. Our vast oceans act as a global thermostat, soaking up the sun's energy and distributing it around the planet. Let's begin our thought experiment. Imagine a switch is flipped. In an instant, every molecule of H2O on Earth is unbound from our planet's gravity and escapes into space. The first thing you would notice wouldn't be the thirst, it would be the silence. The sound of rain on a roof, the rush of a river, the gentle lapping of waves on a shore, all gone. The world would fall into a profound and unsettling quiet. The sky, once a dynamic canvas of white clouds, would become a stark, empty, and permanently clear blue. Every human, every animal, every living creature is, at its core, a bag of water. The moment water vanishes, biology ceases to function. Cells would collapse, tissues would desiccate, and all life would perish in a matter of seconds. Now, let's consider the grandest features of our blue marble, the oceans. What happens when you remove a body of water that is, on average, nearly 4 kilometers deep? You reveal a hidden world. The ocean floors would be exposed to the sky for the first time in billions of years. The immense pressure exerted by trillions of tons of ocean water is a critical force in our planet's geology. Its sudden removal would trigger earthquakes on a scale we can't even imagine. The newly exposed ocean floors would be torn apart by titanic geological convulsions. The great salt flats left behind would be a sight to behold. This ooze, now instantly dehydrated, would become an immeasurable volume of fine dust. The slightest breeze would lift this dust into the atmosphere, creating planet-engulfing dust storms that would dwarf anything seen on Mars. Weather, as we experience it, is fundamentally a story about water. So, in a world without water, what happens to the weather? In short, it stops. There would be no more rain, no snow, no fog, no clouds, no humidity. The temperature extremes would become brutal and unforgiving. By day, the surface would bake under the unfiltered glare of the sun, reaching scorching temperatures well above the boiling point of water. But at night, temperatures would plummet to far below freezing. The wind would become the only remaining element of what we once called weather. These would not be winds carrying moisture and the promise of rain, but dry, superheated gales on the day side and frigid, life-leeching blasts on the night side. We've already established that the disappearance of water would cause an instantaneous end for all surface life, but the story of life's demise doesn't end there. Our planet is home to creatures that exist in the most extreme environments imaginable. These are the extremophiles. Could any of them survive this ultimate apocalypse? The catastrophic geological shifts would likely fracture the crust so severely that even these last hidden pockets of water would be exposed and lost to space. In the end, the answer is no. Nothing would survive. The atmosphere of our dry Earth would undergo a radical transformation. The geological chaos would begin to pump other gases into the air. Chief among these would be carbon dioxide. The atmosphere would become thicker and thicker, laden with CO2. We have a terrifying example of this process in our own solar system, Venus. This is the fate that would await our dry Earth. The initial phase of fire and ice would slowly give way to a new equilibrium, a planet permanently on fire. Over millions of years, the face of our waterless planet would continue to change. sculpted by forces we rarely see in action today. Without water, this process stops. The landscape would become one of stark, preserved antiquity, a static and unchanging death mask. So we return from our journey to a dead Earth, back to our own world, shimmering with its brilliant blue oceans and teeming with life. This thought experiment serves a profound purpose. It shows us that water is not just a resource, it is the conductor of the entire planetary orchestra. Our world is a beautiful anomaly in the vast, dark cosmos, and the reason for that is the simple, elegant, and life-giving molecule of water. It is, quite simply, everything.